Hello, I'm Marton from Romania and I'm here today to present you about BigQuery. So my session will be about supercharging data analytics with BigQuery. So let's get started. About me a bit. So I'm among the top tier Romanian on Stack Overflow. I have a really strong profile answering a lot of questions and providing community work. I'm also a Google developer expert on cloud technologies since 2016 and I craft web and mobile application, mostly backend programmer and system architect at a local company. My favorite products are BigQuery, Redis, and I consider myself very versatile in database systems and so on. You can find my sessions and previous slides on SlideShare under Marton Kodok, Twitter as the Twitter handler the same, and my stage name on Stack Overflow or GitHub is Pentium 10. So welcome, let's see what's on our agenda. So we are going to see what is BigQuery, how we are going to how we are going to build, train and evaluate and execute machine learning models. We will see some practical use cases and we will have a segment and recommend example using BigQuery ML. So let's start. For me, a legacy system and a legacy reporting system means that you eventually have a database where you have master-slave architecture and you are able to load balance all these things in order to have the throughput that you need in your system. Of course, you have eventually scheduled tasks or cron job to run batch processing. You can do this in the midnight or when there is no load or constantly, and you build out reporting and analytics in your system. This system could be on-premise, it could be on a cloud vendor, a virtual machine, or on a droplet, where it is. It doesn't matter. My presentation introduces BigQuery as a concept to this architecture. So serverless, as BigQuery is a managed service and it's part of the Google Cloud Platform. On Google Cloud Platform, this system can be a complementary to an existing system. So you can leave your project where it is right now, even on-premise or on a cloud vendor, and you can externalize complementary your database to BigQuery. And then you have another product, Data Studio. With Data Studio, everyone can build out quickly charts and they are able to have business insights much more faster because it's strictly related to a database tool. So you don't need to leave out the environment. You get the plots, the line charts and every 30 type of charts at your hand from your queries. So why BigQuery? So BigQuery, and what is BigQuery? BigQuery is analytics as a service, a data warehouse in the cloud on Google Cloud Platform. It has familiar DB structure, table, columns, views, also has structs, nested and JSON notations, which comes very helpful nowadays that you want to store unstructured data next to structured. And as it's a managed service, we need to mention that it has a price component. So it has a decent pricing because storage is $20 and queries is 4 terabytes. So as you imagine, a terabyte is only 5 to query it and 20 to store it. So if you would have, I don't know, a petabyte of storage, you will have $20,000 here, which on an on-premise you cannot afford or you cannot build out a cluster from it. And it's SQL 2011 based, which means that it has all the modern things that SQL already offers. You can work quickly with JSON nested and a lot of additional things. One of my favorite features is that it has a syntax for JavaScript user-defined functions. That actually let us to use tremendous things inside the SQL engine. So just an example, eventually if you store in a database column, a text, and eventually you want to analyze the sentiment of the text, you could inline a JavaScript library for sentiment analysis, and you can run that part of your select statement. So that's actually a very interesting use case, and you can use the JavaScript framework or palette, whatever, for all kind of user-defined functions. Now, there is BigQuery ML, which is the topic for today. It enables users to create machine learning models with SQL. We will see that next. Of course, this is a managed infrastructure. You need to only have your credit card attached to the project, and you don't need sysadmins. It's already taken care by Google. You don't need to manage capacity. You don't need to manage disk size. There is no index concept, so everything is taken care of you. You just put your data and it can scale into exabytes. It integrates with Cloud SQL and other Google products. So if you have a database, for example, a Postgres or MySQL or Manus SQL, even Oracle, you can cross-join BigQuery with them. Or if you have a file on the storage, you can cross-join with the syntax like it was a table. Or if you have an Excel in Google Sheets, you can cross-join the tables as it was a table. And also it have pops-up connectors to actually have stream processing and all these benefits. So eventually, if you don't know about these features, you should try out what benefits are when you turn with your data to BigQuery. So, how do you load data into BigQuery? You can load from file. It can be up to 5 terabytes. Yeah, you can actually create a large JSON or CSV from your current system, and you can make that 5 terabyte large, and that will be ingested inside BigQuery. You can stream rows, which is extremely powerful as it allows 1 million rows per second. So you're right, 1 million rows. So I would say that in an IoT device, an IoT world, the number of events that could happen is a good example for this. So imagine, I don't know, a drone or a car, autonomous car, generating events like and these need to be streamed real time to the cloud. BigQuery supports that up to 1 million rows. It can use Lambda functions to load data into BigQuery. You can have an observer trigger based on different triggers, and then automatically data gets ingested or imported into the BigQuery. As I mentioned, we can join with Cloud SQL, ability to cross-join with MySQL and Progress, and others as well. I will have an example in a moment for that. Also, it has pipelines capability to do ETL with Fluentd, Kafka, Google Data Flow. It can export from connected services like other products from Google like Firestore, Billing, Audit Logs, Stackdriver, and it has a strong integration with Firebase. As nowadays people tend to develop more on Firebase, they can eventually get the raw analytics messaging and performance monitoring predictions details out to BigQuery for raw analysis. So let's dive in a couple of examples. So let's say that we have our application outside of Google Cloud Platform, and I want to get started to join with our database. What and how I need to do in order to accomplish this? So the solution is a syntax external query. To run external query, you need to first set up your stack in order to work with BigQuery. So eventually in this situation, when you have, let's say, on-premise or on other system, you have a database, you need to set up a replica inside Google Cloud Platform. You see here, this is Google Cloud Platform in the chart. How do you do that? You have a VPN service where you can have a gateway between your on-premise and Google Cloud Platform. And after the VPN is set up, you are able to set replica and be like, I don't know, the fourth instance of your database stack, a replica in Cloud SQL. Then inside BigQuery, you are able to select not only from BigQuery, but you can combine, and you can actually combine BigQuery with regular SQL, and we can build reports. This is one way, and this is just a complex example how you can achieve querying, combine queries from other SQL existing systems you have. So in practice, how does this look like? So it looks like there is a special syntax, left join, external query. You have a parameter with connection ID, you put there the connection string, and then you run the select from orders. Orders is a table which is not inside BigQuery, it's inside our external system. And you can join that based on a table like transaction facts, which are inside BigQuery, and eventually customers, which is in BigQuery. So you can have an external SQL system which is available in Cloud SQL offering that you can query together with BigQuery. I love this feature, and we use it to actually enrich and keep all our data. We store a lot of events of all our transactions and the website events. I will have a lot more examples from the website profiles, and for that I'm going to use a bit from the how a website is structured and what events it's emitting and so on. So just to have a conclusion where to use BigQuery, it's okay for optimizing product pages, but in order to optimize product pages, you need to find, store, and analyze user actions. So you eventually have, let's say, Google Analytics snippet integrated in your web platform or mobile application, but that doesn't send the user. It only sends events. The user is not a context there. You don't know who was exactly that person. But you can build out a little snippet that you can route the event that you emit into BigQuery, and then you have a way to join with your business application, with your profile database, and you can find out which users are doing what. So this is a great example to actually find out the user hits, and you store the data and then analyze in BigQuery. Another example is email engagement. You could have an email marketing platform, let's say, where you send thousands or even millions of emails every month, and you want to track every open and every click in order to improve marketing scope and businesses. So you are able to extract all those events and eventually track and measure and store in BigQuery. Also, you can have A/B split test on a marketing campaign. So this is a great example to store this heavy data into BigQuery and later write SQL in order to build out business insight or marketing campaigns. Funnel analysis is also a good example because all the data that you collect you are able to actually visualize, and you are able to get an improvement, a business insight out from it. And you can pre-sell products, or you can tweak, customize certain pages in your user flow. So our benefits: we like BigQuery because it has SQL language and we can run big data queries. Also, we like because it's a system outside of our project, and ad hoc queries can be executed by analysts or by sales. They can come with their tools and they can run queries against BigQuery. They are not affecting production system. We don't need to care about capacity problems. The system is free and you can use it as powerful as you wish. We are no more throwing away or expiring aggregating all data. This means that we end up adding a lot of data collection, and we are choosing a minimum granularity for that. We are not aggregating per day in order to have less data. It's serverless, so we don't need to care about any capacity, system stack and everything. We don't need to care about provisioning, deploying everything. It's no running out of resources, and no more focus on large-scale execution plan. suppose if you, for example, run a large uh, Scala job or Spark job, you are able to run it for 4 hours, then you get an error. Heap out of space. Oh, problem. You go to Google, you search on it, you eventually find some parameters on Stack Overflow, how to tune it, and you start again. So this is not a good example in this word, but on BigQuery, this is actually exabyte scale, so the queries are there and it runs. It may not run like that, but it will be finished in a couple of minutes for you. Okay, this actually lets us to use BigQuery for creating live dashboards. How we do live dashboards? There is Google Data Studio, which is actually a visualization and a chart system, and there you can build out dashboards. You have here an example dashboards for an e-commerce campaign, and of course this dashboard to build, it takes like, I don't know, 2 weeks, because it has, I don't know, like 35 up to 40 queries. You need to individually add a lot of queries, but they are live. You can choose the data, and if your event stream is live, it's real time, then everything, it will be up to the latest granularity which you have, eventually up to the latest minute. Okay, that's some features about BigQuery in order to show you how powerful it is. And now let's see what is BigQuery ML, our current topic. So BigQuery ML is machine learning inside SQL. So you are able to create SQL syntaxes to execute ML initiatives. You can integrate models in SQL to increase development time, and you can automate common machine learning tasks, and you can hyperparameter tuning by changing different models. So where can we put this offering? So let's say that eventually, let's take TensorFlow, because nowadays is the de facto way to build out machine learning custom models. For TensorFlow, you need a data scientists, and you can deploy state-of-art custom model. It requires deep understanding of machine learning and programming. On the other side, if you move down on the table, we have AutoML and Cloud ML APIs, which require only developer or eventually a browser and some zip file in order to get started. So here you can provide Google provided models. You can upload, let's say, a zip files, and you can run on Google provided models. It requires almost no machine learning knowledge. Those are the two sideways, scientist and developer. And in the middle, we have the SQL expert. So somebody who knows SQL now has the ability to build and deploy custom model. And it requires only basic understanding of machine learning. It's a SQL syntax. You need to understand the name of the model that you are using, what kind of hyperparameter it is. You can fine-tune those hyperparameters, and you can actually get insight much more easier, because creating a model is just like creating a table. So nowadays I see people tend to block with machine learning. So I put here some common mindset blockers. So what people are actually saying, machine learning is hard, we don't have a dedicated team. But when we look with BigQuery, you only need developers who have good SQL skills. You don't need to have a machine learning dedicated team. You can extend your current stack with machine learning, as it's no longer a steep learning curve. You can understand how to connect pieces of tabular data. So I didn't mention so far, but all the machine learning logic is based on tabular data, because we are dealing with tables here. You can fulfill a business requirement from the analyzing and creating a model from the tabular data. You can use the cloud benefits and have BigQuery ML as a complementary system. So I see that you keep your current application where it is, but you can send also the data as a complementary system, as a second, as a third system to BigQuery, and then you can actually leverage all these product offerings. Also, for BigQuery, you don't need a large budget to add your first machine learning implementation inside your application. So it increases innovation and you can work on fun stuff. Often people, they are bored with their current stack, how old the application is, and they are looking to explore new worlds. Cloud and BigQuery is one way to actually work on fun stuff. So we have here on the screen the supported models right now what BigQuery offers. And look here, so there are linear regression for forecasting. You can have binary multi-class regression, logistic regression for classification, like it's black or white, or you can have labels up to 50 unique values. You can run k-means clustering for data segmentation. You can have matrix factorization, which is a recommendation engine. I will have examples for all this. And my favorite is that if you have a TensorFlow model, you can import the TensorFlow model for prediction in BigQuery. This means that if you get your hand on a model, which either you find on the internet or someone else trained and built that for you, you can import and run on your tabular data in BigQuery. So, some use cases in order to understand better what we are going to show today for you. We have e-commerce use cases here. For example, using logistic regression in order to predict if a user converts or actually purchases. So we are able to actually have features. The features are the dimension attributes of a profile that will drive our machine learning model, and based on that we have a train data set, and then we can have an eval data set, and you can actually predict a prediction that customer will convert or will purchase a product from your website or shop. You can have customer lifetime value. It's a number like this user will eventually be a $5,000 customer. You can prioritize marketing campaigns if you know these answers. So why are these examples here? These examples are here because the marketing team often goes to programmers and asks about, give me all the users ranked by a certain condition, and they need to do this for the entire database. And then the marketing team only needs, for example, the top 1000 item. So for example, it could be a machine learning model to pick out what are and who are the top 1000 users in your list, and you send only for them a marketing campaign or a discount or a coupon or some advertising, all kind of operations here. Of course, we have k-means clustering, where you can do customer segmentation. So often marketing team are not leveraging segmentation, and it's not leveraging automatic segmentation to build out clusters. So the algorithm may be able to detect clusters that the marketing team later can use for showing and detecting their common interest and their spending habits. Having knowledge of those information, it allows to better customize their efforts to this audience group. Okay, so let's see examples. How we get started with BigQuery ML. So, just a short example. We are going to create a model that will predict whether a website visitor will make a transaction. So, we need to know the attributes of the visitor, and we need to have a previously known data in order to train that the user how is being recognized for transaction. We are going to use create model SQL syntax we are going to use machine learning evaluate function and machine learning predict function. Right. So, clear example. What we have here. So I'm starting with explaining selecting features. Selecting features is here on the SQL. For the sake of example and to be minimalistic, there is only 4 features included in this example, 4 columns, but it can be 50 columns or it can be even 200 columns. And this is system operation from user agent, eventually if it's a mobile device, what countries and how many page views the user had already in our platform. This data comes from a Google Analytics data warehouse. So I didn't mention, but Google Analytics raw data can be exported into BigQuery. So that's a product offering in Google Cloud Platform. But you can eventually measure and create a table by having your own events routed to this table or a similar table. Then we need the label. So BigQuery names that we need to create exactly a label column. This is actually showing that the user has a transaction or not. So this is our training data set. The training data set uses a time frame which we will use just for training. We will use another time slot in order to eval the dataset. So the syntax is create model, like it was a create table syntax. In the options you have the model type. Of course here with comma you can add additional options, and just for the sake of example I didn't include it, but those are actually the hyperparameters and those are hyperparameter tuning. So you need to read out what options logistic regression lets you to tune, and you can improve your model version 2, version 5, version 10 and so on by tuning the parameters and by choosing different features. This query, as you see here, it runs in 7 minutes. Of course, so it's a machine learning creation model, so it doesn't run like that. It needs to create the model. And here you have information like what kind of processing bytes have been built for you. So we have the model created. Then we want to see how it evaluates with our another data set. Here we are using another data range which was not part of the train, and we are having the same columns with label included and the features, and we are evaluating, and I'm selecting everything from the evaluation return, and you can see here accuracy, you can see here other parameters which are important for you in order to fine-tune and eventually to compare different models, because as you change models you will know that the direction is good or worse, and you can test out this. And then the third one is actually predicting something. So how do we predict things? We are adding the 4 features that we need as an input, because these are the features. You can observe here that there is no label column because label is actually predicted. So if a new visitor comes to your website and you are obtaining these, let's say 4 informations from the user, you are able to run a prediction for it, and it will return, for example, for these values, it returns 68% of probability that the user will convert. For here you have 51. This is just a minimum example that fits on the screen. Of course you need to test and build up. Often people ask me that why is our number are not 95%. So I would explain that in tabular dataset you accept like 75 up to 80% probabilities. In image processing or video or audio processing machine learning, you need to be 99% accuracy in order to have a good results. But in tabular data you can rank users based on a lot of factors. You don't need to be that accurate for that. You can train your model to be much more accurate than these couple of examples on the screen. So next example, K-means clustering. And I would say here that you can segment your customer, or you can analyze your data quality. It offers some options and defaults which you can fine tune, and you can also use additional models here. So what's the syntax? It's create model type like K-means, and then you can use the predict. Also, it has a special function like centroid in order to find out the centroid of the cluster. How you can use this in your projects? You need to encode your features in a yes, no, or boolean method. It could be even true, false, or it could be 1, zeros. Let's say like a booking.com example. The features could be like a property has a microwave, has a kitchen, has a TV, has a bathroom. You can build out same features in your product line and in your application. And you can apply clustering on the encoded data. Of course, the charts can be visualized in many ways, and you need to spend time in order to visualize and to understand the data, in order to know which are the most value and how, for example, customer lifetime value is behaving in your system. Here, this is another example, but in a much more easier example, I would say that you have clusters like the red cluster identified, you have the centroid availability with the function value, and you can detect outliers, like why some values are far from the centroid. For example, you can, on my previous example, booking.com can flag that, for example, this property is far from centroid because it forget to set that they have a kitchen or they have a bathroom, and that puts them far from the centroid. You can clean this data, for example. Now we arrive to matrix factorization. Matrix factorization is one of my favorite models because it allows you to do product recommendation, and it's a tool for marketing campaign optimization. And I would straightly jump to the example because that's much more easier to understand. For a matrix factorization, we need three things. We need the user, we need the item, which is the product, and we need a number or a rating of the product. So look at this matrix, because these three values form a matrix. So we have here John, who actually loves fruits and sweets. Or we have here Peter, who loves all our products. It also loves coffee. The marketing team eventually comes to you to find out, and eventually you have, like, say 25 million users, and they have budget for only 1,000 people to offer discounts, vouchers, coupons, or specific marketing campaigns. And they want to optimize coffee, because coffee is not used by the users, and they want to rank or order by the users based on a machine learning logic. So matrix factorization is something that you can use in this situation. So it can rephrase the problem like you have a bunch of zeros here, and it will assign values for previously unknown values, zeros in our case. So look here, after the reconstructed model for coffee, we are able to see that some users got some prediction values, which further means that we can sort this table and we can put Peter as a user who probably will Peter already bought coffee, so that's something outside. But for example, Jennifer will probably convert to coffee because it has a high ranking. Then we have Greg and we have Alice, so we can send a marketing campaign to all these users. In practice, how this works: so we have the create model, where we have the option as a model type matrix factorization, and we have to build out a query from our existing data sets using the three columns: user, item, and rating. Then we can use the predict function like this. But be aware that this will return every user item pair for you. So it will build out the entire user recommendation scale, which could be trillions of rows. In order to recommend for a specific user, you have select from recommend the same model syntax up to here, and here you have an input parameter, the user ID or John, as in our example. Then I'm also having an exclusion, like I want to exclude all the items which were already purchased by John. So that's why I'm getting only back a recommendation of the products that John didn't buy, and I can prioritize that in our campaign. So as a final example, we have TensorFlow models for prediction. TensorFlow model is being defined with the model type TensorFlow, and you have a path of Google Cloud Storage. This path needs to be a folder, so you eventually get a hold of your model, of a TensorFlow model, from the internet or from a data scientist. You upload it to the cloud storage, and then you can use on tabular data. The model size limit must be under 250 megabytes, but people don't know that some TensorFlow models are a couple of kilobytes or even like a couple of megabytes, so 250 is a decent limit for that. In order to build out versioning 2, versioning 3 of your models, because in BigQuery you can create as many models as you want, because that's actually is creating as many tables as you want for your situation. BigQuery offers you different charts in order to analyze the models and to compare them. You can have access to different kind of information in order to see that if a model is performing better or hopefully performing better than your others, and you can fine-tune different hyperparameters in that model definition, where you can put additional information and hyperparameters to the model. So before jumping to the conclusion, I will show you some examples in practice. So let's run, for example, a logistic regression example. What we have here, we have Google Collaboratory, and we are going to look at the same example as was in the screen. So I have here our features, and the label is actually used for training our data set. This is actually just a select, it doesn't have any special syntax. I'm just exploring data and visualizing how our data looks. Then we have the create model syntax, where the select is defined as the input for create model. After the model is created, then we have evaluate, and for evaluate we have the output, and then we can fine tune. We can go back here, and create another model like 2 or 20 or 34, whatever. We can build out different models for that. Once our model is ready, then we can use the predict function. The predict function takes the features as an input, and of course this is another user base. So if you can have a training data set, let's say from last year, and you can predict for this week's user in order to see how they are ranked. And based on this, the predicted label is being totalized in order to see based on country how it works, but you can run individually for each user, as I show you in the slides. Okay, let's go for another example. Another example would be k-means clustering. So k-means clustering. So here is a pre-aggregated data for you. This is just a select. I created a table. It has the station name, is weekday, duration, number of trims is already aggregated, bikes is already aggregated, and distance from city center. So what is this data? This data is from London, bicycle stats. So that's a public data from where I built out these statistics. And based on this, you are able to create a k-means model with a number of clusters I set as 5, and we are not using these parameters in our features. So station name is weekday is not a feature, but the rest of the columns are. So duration, number of trips, bikes count, distance from city center is used as a feature in our model. So after the model is created, we are able to predict, and we are able to get output of the, let's say, centroid ID, because this is not cluster, but it's some kind of cluster, like cluster 4, cluster 5 for this. But in order to get better, also I filtered the data set just for a station name or stations that produce fewer lizards for our example to have clear on the interface. You can have a bit of pivoting in order to see the values of the clusters by using the centroid function and the values returned by the centroid function. So what we have here, actually these numbers represented on the screen are looking like this. So we can name cluster 1 where there are long trips, long bike trips, and there are fewer trips, and they have a lot of bikes there, and they are far from the distance from the city center. So it may be stations or bicycle rent plans where they are far from the city and people are taking for a longer trips. Then, for example, we can have cluster 3 where we have a lot of number of trips. It's extremely close to the city center, and they are average or medium bikes number. So this is, for example, it could be something like a touristic area where there are a lot of trips taken from A to B. So why is this? Why and how you can use this model inside your marketing campaign? Eventually, if you want to try out a new lock or a new, I don't know, bicycle or a new type of service, you are able to choose a cluster of stations where you want to start implementing that choice first. I will quickly jump to our last example, which is text classification using pre-built TensorFlow, which I want to show you the feature and how this works to predict with TensorFlow model. So, in order to understand what we are going to build here, I've used Hacker News as data source. I didn't mention, but BigQuery offers public data sets, and Hacker News or Stack Overflow or GitHub public repos are included in BigQuery, and you can analyze it right now. You can BigQuery offers 1 terabyte monthly for free analysis, so go and check it out. So from Hacker News, I actually want to figure out whether the article title came from GitHub, New York Times, or from TechCrunch. So we are exploring first our data. We have here URL, title, and score as a data, but we are going to use eventually just the title. In order to understand further, I created a summary of articles to actually see how and which platforms are referenced many times on Reddit. So I was able to build out this table. Then I further analyzed data in order to choose only our targeted sources, which are GitHub, New York Times, and TechCrunch, which is still select in order to understand our data. And then I found a pre-trained model used and created by Lakshmanan, and it has been published to GitHub. And the source of the folder can be exported. I mean, this is a folder and it's uploaded here on the cloud storage. If I know that this model is built by Lak, then I can use in my BigQuery syntax. So I run create replace model with model type TensorFlow, and I use this path in order to note where is my TensorFlow already trained model uploaded. And that's all. After that, I'm able to predict it. And how do I predict? I'm using the machine learning predict, and I'm adding in the title as an input parameter. And I will get output like dance and the input. The dance is an array of factors based on our sources. So in order to understand better and how to use with a new data, I created a simple example from you. And the simple example is putting inline your input data. So actually these titles are the one we want to be predicted. And then there is a special struct in order to select from our previous known array, ordering by rank and choosing the top, like limit one item, in order to see that New York Times is predicted for this title. And for this title, TechCrunch is predicted. For this title, GitHub is predicted. So actually this you can take this further, these examples, but the conclusion is that if you obtain a pre-trained model on TensorFlow and if you upload that to Google Cloud Storage, you can run a create model statement. You can then use select and machine learning predict statement on tabular data or on your business data. Let's go back to our slides and name the conclusions. So we have considerations like we can run the process daily, we can create as many models as we want, we can determine hyperparameters, we can eventually tune those, we can surface the results and route them for inspection and improvement. So whenever you do an A/B testing, you need to eventually see if a model performs better than the previous model. And that's actually good in order to repeat and automate things. So, benefits of BigQuery ML. Democratize the use of machine learning by empowering data analytics to build and run models using existing database tools, eventually even spreadsheets. You need to have only a generalist team. Models are trained using SQL. You don't need to run for a data scientist team. You can increase innovation, and a model serves a purpose. So it's easy to change, recycle. You can do that many times during a day. The possibilities are endless. Even if you are in marketing, retail, or industrial, or media and gaming, you can pick and eventually build out recommendation or predictions. I don't know, for industrial, like prediction maintenance needs, or in the gaming industry to personalize content or predict game difficulty based on machine learning logic. For marketing, you can personalize ads, email, web page content, or even predict funnel conversion. This concludes my talk about BigQuery ML, and you can find my previous slides also on slideshare.net/Marton Kodok. Thank you for having me here, and eventually I can answer any questions on Twitter, See you, bye.